The use of AI in healthcare is growing fast. But how do you know if a clinical AI tool is safe in practice? Hi, I'm Harris Schwabe, a medical physicist and CEO at Newton's Tree. In this video, I'll guide you through how to run clinical risk management for AI. We'll go step by step through how to assess, mitigate, and monitor the unique risks posed by medical AI so that it's not just safe in theory, but in your real-world workflows. Firstly, AI, especially deep learning systems, are unstable in ways we don't intuitively grasp. These systems can behave unpredictably due to feedback loops, correction cascades, and unstable data dependencies. Secondly, the risks are not isolated to the AI alone. They often come from how the AI interacts with the environment or even with staff behavior. That's why clinical risk management for AI must involve experts who understand both sides, the clinical workflow and the AI technology. This is not something a generalist can safely oversee. Now, there are three core stages in clinical risk management for AI: risk analysis, risk control, and risk evaluation. Let's break those down. Step 1, risk analysis. This is all about identifying what could go wrong, and there's two questions that will help you. Firstly, what are the types of technologies involved? For example, is this a classification model or a large language model? Or maybe it's a predictive risk score. And then what are the known failure modes of that kind of technology? To give you a flavor, large language models, for instance, might hallucinate results or misinterpret prompts, even for clinical questions that seem clear to humans. You may have seen the examples where large language models dangerously miscalculate drug doses. And then step 2, risk control. Here we look at how we can prevent or mitigate the risks that we've just identified. Some examples might include setting up technical safeguards like input validation, where you're monitoring the quality or validity of input data, or perhaps output constraints, which prevent the AI creating invalid or nonsensical results. You can also create guardrails in the workflow itself, like requiring human verification before an action is taken, or even redesigning the user interface altogether to reduce the chance of critical errors being missed. Don't forget, controls must match the level of risk. High severity harms need high assurance controls. And then step 3, risk evaluation. Once controls are in place, we need to evaluate whether the residual risk, the risk that remains, is acceptable. That decision must be informed by both the clinical context and the regulatory standards. In the United Kingdom, this might include DCB 0129 for suppliers or DCB 0160 for implementers. Now, clinical risk management isn't a one-time process. Once deployed, AI tools must be monitored. That includes watching for shifts in data or usage patterns, and then logging and investigating incidents, and then finally updating your risk file as the product or context evolves. So, to recap, AI has unique and often invisible risks. Clinical risk management must be expert-led and context-specific. Always go through risk analysis, control, and evaluation, and then monitor it in deployment. If this helped you, give us a like, subscribe, and drop a comment. We'd love to hear how your team is managing clinical risk in AI. And if you're planning to deploy AI in your hospital, Newton's Tree can help. We work with hospitals to build safe, effective, and sustainable AI deployments. Thanks for watching, and I'll see you in the next video.